Hey guys, I'm Brittany,
I'm George.
and today we're going to be going over linear motion and this question we prepared for you guys. So the question is, you throw a ball to a basket with a constant velocity of 2 meters per second. It takes 5 seconds for the ball to reach the basket. The ball has a mass of 1 kilogram. What is the distance to the basket if the angle is 45 degrees?
Okay, so now we're gonna pause the video so you guys can have time to solve it. Alright, so the student must realize that the acceleration in the x direction is 0 because the velocity is constant. And the student must realize which kinematics equation must be used from the given variables.
Okay, the student must also recognize that we're looking for distance in the x direction, so all variables in the y direction are non-applicable. The student must also know how to identify the velocity in the x and y direction for the given angle. Okay, so now we're going to start breaking down the problem. So first we're going to identify all of the inventory and our primary goal. So we know that velocity initial equals 2 meters per second. And we know that time equals 5 seconds. We know that the angle given is 45 degrees. We know that because velocity is constant, acceleration in the x direction is 0, and the acceleration in the y direction is going to equal negative g. Okay. Oh, and we also know that the mass is 1 kilogram. So our goal for this problem is to find the distance it takes for the ball to reach the basket.
Alright, so the next part of to figuring out the question is to draw a visualization of the problem. So we have the man. We have the ball, and he throws the ball to the basket. And then this angle would be 45 degrees. Alright, so you're going to want to get your velocity vector. And you're going to want to get it in terms of x and in terms of y. And you want to get the angle.
Okay. So our justification for this problem is that because acceleration is constant, we can use all kinematics equations.
Alright, so the first thing you want to do is find your velocity in terms of x. So that's going to be v initial of x plus acceleration in the x direction times t. But your acceleration is 0 since the velocity is constant, so that would be 0. So you have your v of x is equal to v initial of x. So then you come back to your triangle and you have cosine of 45 degrees is equal to v of x over v. So then you're trying to find your v of x, so you multiply by the velocity. So then that cancels out. So then you have velocity times cosine 45 degrees. Okay, so now we're going to try to find distance in the x direction. So we have x is equal to x initial plus v of x times time plus 1/2 a t squared. Because our x initial is 0 plus our v of x, which we solved over there, so the velocity is 2 meters per second times cosine of 45 degrees times our time, which is 5 seconds. And because our velocity is constant, our acceleration would be 0, so this part cancels out. And the answer would end up being 7 meters.
Okay, so now I'm going to go over alternate ways students may have solved this problem. So we're given an angle of 45 degrees, so we know we have to find velocity in the x direction, but students may have also solved for velocity in the y direction. So if they did that, they would have gotten v of y equals the initial y plus acceleration in the y direction times time. And then we get that v of y equals the initial y minus g of t, since acceleration, or since gravity is the only force acting on acceleration. And then to get velocity in the y direction, we know that it's going to be v sine 45 degrees equals vy, because if we look here, it is opposite over the hypotenuse, so that would be sine. So then we plug that in over here, we get that v sine 45 is 2 meters per second, sine 45 degrees minus 9.8 meters per second squared times 5 seconds. Okay, so after we plug this in, you get your v of y. But if you realize there's no initial distance given in the y direction, so that would be like the height of the man. So we can't find the final height for this problem. So you wouldn't be able to continue solving given v of y. However, some students may have still used this value to solve the equation. Another problem students may have faced when approaching this problem, when solving in the x direction, they may have still plugged in the value of gravity for acceleration, but that's also incorrect because we're just looking at the motion in the x direction, and because velocity is constant, we will know that acceleration is 0. So plugging in gravity into the equation would be incorrect as well.
Alright, thanks for watching, guys. This concludes our video on how to approach a linear motion problem.
If you guys liked our video, go on YouTube and give us a thumbs up, subscriptions below. Thanks for watching.